Hey guys, Mike here from Applied Engineering and Design, and in this tutorial we're going to go through setting up your post-processor with RhinoCAM. I have a bunch of modifications that I've made to mine, and so I figured it'd be good to do a tutorial for you guys to see some of the neat tricks you can do. I've had to make some tweaks based on some of the products that I'm making, or just the way I like my code to be spit out, when we edit it and everything. So let's go ahead and get started. From your basic Rhino window here with RhinoCAM open in your machining browser on the left here, normally you have your post processor selected here under your machining job. And right now I have a 4-axis machine selected. And my post processor is set up with Haas with cut comp, which is the post processor is set up with the ability to set up for cutter compensation. So if you go ahead and double click this, it's going to pop up this window that shows your current post processor. And if you click the little menu, you can see there's all kinds of stuff. And I've used several of these already, and they're all pretty good. I've used this Axes ATC. I've used the Haas, and I've used some Miltronics with the Centurion 6 right here. I've also used some custom tweaked ones for some water jets as well. So we're going to go ahead and leave this on Haas with cut comp. There's some other settings in here that are pretty cool. You can send your file to Notepad, which is when you post it, it normally pops up in Notepad. You can do some quick edits or any changes you might want to do for final saving and bring it over to your CNC machine. In another tutorial, I'm actually working on some plugins for the program called Adobe Brackets, which I think is a pretty cool program, free, text editor for guys who program and write code for websites and everything, and they do syntax highlighting. So once they don't have a syntax highlighter for G-code, so I'm working on setting up a custom syntax highlighter that I'll put out on our website as well. And then it would be cool. You can send it right to Brackets. It'll open it up, and you can see it right away. But if you have something like Predator or one of the other CNC specific text editors, you can go ahead and set that up in here as well. So what we're going to do is we're going to go into the post processor and click Edit, and it's going to open up this file right here, this little window. Now some of them may open up and say that it's a different version, which is fine. Just go ahead and click through that till you get to this window here. Some of the changes that I've made, I've added the comments section here. So let's go through everything. We'll go through all the windows here, and we can talk about some of the things you can do. So file control here, most of this is set up for the machine correctly. Now, like I said, this is, I do very, very minimal tweaks. I don't want to go messing anything up, but as I learn more about it, if I learn anything, I'll do some extra videos and add some more for you guys, some of the features I may learn. But for here, your file start reading character, that's basically going to be your initial character that's at the top and at the end of the file, and this is what Haas expects when you load a program. You can set your mode in absolute or incremental right here just by clicking it, and that's going to set your G90 or G91. I use absolute. And under your comments here, if it's not by default selected, you can turn on your output comments, and that's going to set your comments. You can set a start and an end character, and if you need to change this for your post processor, this is where you change it. So I like to leave that on because it inserts a nice comment about the tool and about some other things as well. And you can also determine whether or not you want your sequence number spit out for your comment. So I leave that off. Typically, I don't use sequence numbers. Some people like them, some people don't. It can make the code a little messy, but you have a couple cool settings here as well. If you turn your sequence numbers on, you set your prefix to N or whatever letter it needs. You can set your increment to go every 1, every 2, every 10, just by changing this value here. And you can set your start value to 1, 2, 5, 10, whatever you like to. Your leading zeros here, this will tell you your amount of digits. So instead of it saying N1 for your first line, it would say N0001. And that's so certain, it's basically limiting, and once it gets to N9999, it's going to restart back at N0001. Certain controllers need that, some don't. But like I said, I leave sequence numbers off because I think it messes up how nice the code looks when I start looking through it to make changes. Here's your units right here for inch and for metric. Your G20 and your G21, I work in inches, and that gives you that. So your modal output, these should be checked. Your G code, set your modal, feed rate, your coordinate and your spindle speed so that you can leave alone or change it based on what you need to. Your block format here, this is going to give you whether you want a delimiter, space, tab, comment, whether you want a plus sign, and whether you want leading zeros on your blocks as well. So this is cool. This will show how you can set put like a semicolon at the end if you wanted to put a semicolon on there. So we'll output some code here and show you some of the differences as well. Into start end, basically all these are going to be variables. Your start character, sequence pre-character, sequence number. This is going to pull right from this general right here. This is your start character. Here's your sequence prefix. So everything's going to refer back to, if it's got brackets, it's referring back to something. So right here, it gives you your percent sign, whether or not you would have a sequence number right here, and then your G40, G49, G80 to start it up. And at the end as well, you have your sequence number, M05 to turn off the spindle, M09 to turn off your coolant, G28, G91, Z0 to bring the spindle all the way up, M30 to end your program, and then another percent sign. If you go into tool change, you can start looking at some of the other macros and things you can change. So we're going to skip over your sequence number here, and you have your unit code, tool number, M6, and you have the T right in here. So for instance, this will output, say, N0010 for 10, G20 for your units, T1, M6. So this you could actually swap around if you want. If you wanted it to say G20 M6T2, which is typically what I type in MDI, I could change that around. And you have your spindle block, which is going to set up your spindle and your speed, and your output mode, and move to your X and your Y for the first. G43 is going to bring your tool and set your height number. And G54 here automatically puts in the work offset. Now, I work a lot with other offsets other than G54. I keep them loaded in my machine for different projects. So while I'm in here, I'm actually going to go ahead and remove this. All right, so if I show you what this G54 here at the end of a tool change, first load, and your tool change macro, it's hard-coded this G54 into both. If I go ahead and pop up brackets here with some code that I was just making a cube out of, you can see that basically here's your start character, your startup, and here's some comments. Here's my work 0 for G54, and that's set when you add a work 0 item to your machine browser. And some comments of the name of what the operation is. Here's your G20 T3 M6, your spindle setup, your movement, and this is all the stuff corresponds right to here. Here's your G43, and right under behind it is your G54. So now let's say, for instance, I had my work 0 set to G110, which I use a lot when I run on my 4th axis. All of a sudden, I have to go in after it edits the code, and it's gonna, I now have contradicting work offsets here. So what I'm gonna do is come back here, and we're gonna take that out completely, out of both the tool change and the tool first load. All right. And let's go to setup. We'll look through some of this. Setup 0 gives you your coordinate system change. So your linear, next X, Y, Z, rotational axis, direction, angle, feed rate, and rotational feed value. And this kind of goes right to this first movement here. And you can see that it's setting the A axis to 0, which I wasn't even using the 4th axis on this. And your rotate table. These are basically when you set up a new setup in your machine browser. This is the code that it's gonna spit out. So if we go to spindle, now you have some settings here. So you have your block format for your spindle. Spindle code is going to be S, which if I show you right over here in the code, I'll highlight it, what it's going to stick out. And so your S is going to be your spindle speed. So you see S, spindle speed, and spindle arc, which is going to be your direction. So we have here G20 S1527 M3. So what that refers to right here is S1527 RPMs, and our direction is clockwise for M3. You can also see that the M4 and M5 are here as well. And the cool thing it gives you is a sample output, so S0, M3, M4. You can also set your high value here. So basically in this post, this is set to 10,000. So we're going to go ahead and bump this to 12 because that is the highest spindle rate of my system. And when I run aluminum, I do like to run a little faster like that. So otherwise it'll cap it off. So that's cool. So let's go right on to feed rate. And basically, just like that, shows your block format, feed rate code, and add after next motion code, feed rate modes, and your format. You can look at your format here, F, and then the feed rate. So your sample output, F0. And this is going to give you your high value of 700, the low value of 0, and everything else. If you need to adjust anything for which actual Haas machine you have, or whichever controller you're using, you can go ahead and set these in here as well. Go to motion. Here's our two different types of motion. Our G1, our linear motion, and it's just your block format. G code, you have your G1, your X, Y, and Z, and here's your sample output. And your rapid, G0, and you have Z, and then X and Y. So when it rapids the Z first, then does your X and Y together. And down here in your coordinates, you have scale factors for X, Y, and Z, and your number of decimal places that it will do. For circular interpolation, you have your arc code for G02 for clockwise, and your G03 for counterclockwise. And you can do your X, Y, ZX, and YZ interpolation as well with G17, G18, and G19. Some controllers don't support that. This one actually does. So your output format, you do IJ and K and radius, or just radius. And your arc center from here, you have your vector from center to start. I haven't adjusted anything in here, but this shows your sample output, G17, G18, G19, or G02, G03, and then your XYZ, IJ. Pretty cool. To go up into helical, you have two different interpolations for helical and spiral. So this is set to helical. And your G code, nothing is really set in here. I haven't really needed to use it, but everything's come out good. If we go on to multi-axis motion, you have your primary axis A, B, and C. Primary, secondary, and tertiary. Sorry. A is my rotational for my fourth axis. B would be the fifth axis. And this is all set up already for your scale factor, decimal places. And here's your block format, G1, X, Y, Z, A, and then your feed rate for A for your G1. And your G0 also has a feed rate because the A-axis needs a feed rate. For your cutter compensation, you just have cutter compensation left, right, and off. And that shows right here you have your prefix, G41, and then your motional G code. And your D for your tool number, so for your offset. Cutter compensation right for G42 and the same, and cutter compensation off for G40. Pretty straightforward. And cut motion start and end, you can add some custom codes into here. And your cycles code. This is where you get into like your tapping and your drill cycles. You have your cycle G code for G80, your sequences and G code, and the one thing that was important is this optimized cycle output. I didn't have this checked before, and what it would do is it would spit out over here, if you look at this G82 line, it would spit out a G82 and a G80 for every single hole that I would be drilling. So when you come in here, check for your optimized cycle output, make sure that's on, and what it'll do is spit it out nice and clean like this, where it does all your coordinates and then cancels the cycle. And under miscellaneous, here's where you can set some of your M codes. Your coolant off, your mist on, coolant tap, coolant on, coolant flood, through coolant, and all your compensation is automatically set here and grayed out. And your work fixture offsets, you can start with a G as well. And in your variables here, this will show all the different variables that you have to work with. If you needed to go and edit something for somewhere custom, you can refer to these variables to use in your custom code. If we jump back to cycles real quick and you tick it down, you can see here's where all of your different cycles will be. Here's your cycle off, your G80, your standard drill for G81, and here's some of the settings you can do with your optimized cycle output, your standard drill with dwell, your deep drill with your basically your peck drilling, your brake trip, countersink drilling, your G84 for your tap. You can control a lot of this, your rigid tapping. You have a lot of controls over much of these, plus a whole bunch of user-defined drill cycles that you can add. It's very cool. You can customize this, which I love. So let's take a look at some code that pops out. So you can see some of this code here and the way it sets up as well. So now you can see that this G54 is in there. Let's go ahead and open up this file, and we're going to close it. And we're not going to save. And we're going to go ahead and output that file and see what it looks like. So what we're going to do first is we're going to do save, close out of this. All right, let's go ahead and open that file. All right, now that we got our file open here, you can see that this is basically just a 3/4 inch by 3/4 inch by 3/4 inch cube with a bunch of drill holes in it. And if we sort of step through what we're doing, we set our work 0 right there. And we do spotting of all of them. You can see them pop up. And a deep drill, because we peck drill actually made this out of titanium. So we peck drilled through that. And then I profiled it to clean it up. And this was done out of a larger piece at first, and then I went through and reran the drill cycle on all 4 sides. I'm sorry, on 3 of the sides to get all the holes in there. So what I was going to say is now that go back in and we take a look, we can look at the change that I made. If we go back to tool change, we looked at that G54 is now gone. Let's close, and let's go ahead and post this. Right click, post, and it's going to ask me where I want to save it. We're just going to overwrite this cube.nc, post. And if we take a look, you could see it's gone. Great. Now I never have to worry about that as long as I remember to always set my work 0, which I do. I set my work offset register. So that's about it. If you guys have any questions, feel free to send me an email or post in the comments or hit me up on Google+. As always, if you have any ideas for other tutorials you want us to do, let us know and we'll do some more. We should be releasing about 2 of these RhinoCAM tutorials a month, along with some more Rhino tutorials, and we'll be getting into some 3D printing and some more quad stuff as well. So stay tuned for that. Subscribe to the channel and let us know if you guys have any questions. Thank you for listening.